The inspector is likely correct in requiring an outdoor disconnect for the panel fed from the back-to-back meter socket. In multi-family dwellings, each unit is typically required to have its own service disconnect located outdoors. The location of the disconnect should be accessible to the occupant for emergency or maintenance situations. The disconnect for the panel in question will provide convenient access to isolate the electrical service to that particular townhouse. The requirement for fire caulking of all wiring is also appropriate. In multi-family dwellings, fire-rated walls and barriers are used to compartmentalize the building and prevent the spread of fire. Fire caulking of all wiring passing through these fire-rated assemblies ensures that the integrity of the fire barrier is maintained. Regarding direct burial of service entrance rated, or SER, cables, these cables can be directly buried in accordance with the National Electrical Code, or NEC, if they are rated for underground use and are properly protected from physical damage. Service entrance underground, or SEU, cables are specifically designed for direct burial and are suitable for this application without additional protection. However, local regulations may vary. It is always best to check with the local building inspector for specific requirements. The National Electrical Code, or NEC, covers service entrance cable requirements. The main purpose of the service disconnect is to provide a means to quickly and safely de-energize the entire electrical system of a building or dwelling unit. This is crucial in emergency situations such as electrical fires, flooding, or when electrical work needs to be performed safely. The disconnect must be readily accessible to the homeowner or emergency responders. The NEC provides specific guidelines for the location and accessibility of the service disconnect. In multi-family dwellings, the NEC typically requires that each dwelling unit have its own individual service disconnect. This ensures that each tenant has the ability to disconnect power to their unit without affecting other units in the building. The disconnect must be located in a readily accessible location, either inside or outside the dwelling unit. The NEC provides specific guidelines for the type and size of conductors used for service entrance cables. The size of the conductors must be sufficient to carry the calculated load of the dwelling unit. The NEC provides tables and formulas for calculating the load of a dwelling unit based on its square footage, appliances, and other electrical equipment. The NEC also specifies the type of overcurrent protection required for service entrance cables. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect the wiring from overloads and short circuits. The size of the overcurrent protection device must be matched to the ampacity of the service entrance conductors. The NEC provides specific requirements for grounding and bonding of electrical systems. Grounding and bonding are essential for safety, as they provide a path for fault current to flow back to the source, tripping the overcurrent protection device and de-energizing the circuit. The NEC specifies the type and size of grounding and bonding conductors required for service entrance systems. When running electrical wiring through fire-rated walls or floors, it is crucial to maintain the integrity of the fire barrier. The NEC requires that all penetrations through fire-rated assemblies be properly fire-stopped to prevent the spread of fire and smoke. Fire-stopping materials are specifically designed to resist the passage of fire and smoke. These materials are typically applied around the wiring or conduit that penetrates the fire-rated assembly. The NEC provides specific guidelines for the type and installation of fire-stopping materials. Service entrance cables, including service entrance rated, or SER, and service entrance underground, or SEU, cables, are often installed underground to provide a direct connection from the utility transformer to the building's electrical panel. The NEC provides specific requirements for the installation of underground service entrance cables. The depth of burial, type of conduit, and backfill material are all important factors to consider when installing underground service entrance cables. The NEC specifies the minimum depth of burial for underground service entrance cables. The depth of burial depends on the voltage of the cable and the type of area where it is installed. For example, cables installed under driveways or parking lots must be buried deeper than cables installed in grassy areas. The NEC also requires that underground service entrance cables be protected from physical damage. This can be achieved by installing the cables in conduit or by using direct burial rated cables that are specifically designed to withstand the rigors of underground installation. The NEC specifies the type of conduit that is permitted for use with underground service entrance cables. The conduit must be suitable for direct burial and must be resistant to corrosion and physical damage. The NEC also provides guidelines for the type of backfill material that should be used around underground service entrance cables. The backfill material should be free of sharp rocks or other debris that could damage the cable. The local building inspector is responsible for enforcing the NEC and other local electrical codes. The inspector will review the electrical plans for the building and will conduct inspections during and after the construction process to ensure that the electrical work is performed in accordance with the applicable codes. It is important to work closely with the local building inspector to ensure that the electrical installation is safe and code compliant. The inspector can provide valuable guidance and can help to identify any potential problems before they become major issues. Ignoring or violating the NEC or local electrical codes can have serious consequences. The electrical installation may be unsafe and the building may not be approved for occupancy. Additionally, the homeowner or contractor may be subject to fines or other penalties. Service entrance cables are used to bring electrical power from the utility company's transformer to the main electrical panel in a building. These cables are designed to carry a large amount of current and must be installed in accordance with the National Electrical Code, or NEC, to ensure safety. There are several types of service entrance cables, including service entrance rated, or SER, service entrance underground, or SEU, and armored cable. Each type of cable has its own specific applications and installation requirements. Service entrance rated, or SER, cable is a type of cable that is commonly used for above-ground service entrances. It consists of multiple insulated conductors that are wrapped together with a spiral metal armor. The metal armor provides mechanical protection for the conductors and also serves as a grounding path. Service entrance underground, or SEU, cable is a type of cable that is specifically designed for underground service entrances. It consists of multiple insulated conductors that are encased in a waterproof jacket. The jacket protects the conductors from moisture and corrosion. Armored cable, also known as BX cable, is another type of cable that is sometimes used for service entrances. It consists of multiple insulated conductors that are wrapped together with a flexible metal armor. The metal armor provides mechanical protection for the conductors and also serves as a grounding path. The size of the service entrance cable must be sufficient to carry the electrical load of the building. The electrical load is the amount of power that the building is expected to use at any given time. The NEC provides tables and formulas for calculating the electrical load of a building based on its square footage, appliances, and other electrical equipment. The service entrance cable must be properly connected to the utility company's transformer and to the main electrical panel in the building. The connections must be made in accordance with the NEC and must be properly tightened to ensure a secure electrical connection. The service entrance cable must be protected from physical damage. This can be achieved by installing the cable in conduit or by using a cable that is specifically designed to be buried underground. The service entrance cable must be properly grounded to ensure safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. The NEC provides specific requirements for grounding service entrance cables. Fire caulking is a type of sealant that is used to seal penetrations through fire-rated walls and floors. Fire-rated walls and floors are designed to prevent the spread of fire and smoke. When wiring or other equipment penetrates a fire-rated wall or floor, it is important to seal the penetration with fire caulking to maintain the integrity of the fire barrier. Fire caulking is typically made from a silicone-based or intumescent material. Silicone-based fire caulking is heat-resistant and can withstand high temperatures. Intumescent fire caulking expands when exposed to heat, forming a char that seals the penetration and prevents the spread of fire and smoke. Fire caulking must be applied in accordance with the manufacturer's instructions. The penetration must be clean and dry before the fire caulking is applied. The fire caulking must be applied in a continuous bead around the penetration, ensuring that there are no gaps or voids. The depth of the fire caulking must be sufficient to meet the fire rating of the wall or floor. The local building inspector is responsible for ensuring that fire caulking is properly installed. The inspector will review the fire caulking installation during the building inspection process. The purpose of fire-rated walls is to compartmentalize a building in order to slow the spread of fire and smoke. These walls are designed and constructed to withstand fire for a specific period of time, typically measured in hours. The fire resistance rating indicates how long the wall can maintain its structural integrity and prevent the passage of fire and smoke. Building codes specify the required fire resistance rating for different types of walls based on factors such as building occupancy, height, and area. Common fire resistance ratings include 1 hour, 2 hours, and 3 hours. Fire-rated walls are constructed using materials and assemblies that have been tested and listed by independent testing laboratories such as Underwriters Laboratories or all. These materials and assemblies meet specific performance criteria for fire resistance, structural integrity, and smoke control. The design of fire-rated walls includes features such as fire-rated gypsum board, concrete, masonry, and steel studs. These materials provide thermal protection to the underlying structure and help to prevent the spread of fire. Fire-rated walls typically extend from the floor to the underside of the floor or roof above, creating a continuous barrier. Openings in fire-rated walls, such as doors, windows, and penetrations for pipes and ducts, must be protected with fire-rated closures and fire-stopping materials. Fire-rated doors are designed to resist fire and smoke for a specific period of time. They are equipped with self-closing devices and fire-rated hardware. Fire-rated windows are constructed with special glass that can withstand high temperatures without breaking or melting. Fire-stopping materials are used to seal openings around pipes, ducts, and cables that penetrate fire-rated walls. These materials prevent the passage of fire and smoke through the openings. Regular inspections and maintenance are essential to ensure the continued effectiveness of fire-rated walls. Any damage or deterioration to the wall, such as cracks or holes, should be repaired promptly. Fire-rated walls play a critical role in protecting building occupants and minimizing property damage in the event of a fire. By slowing the spread of fire and smoke, they provide valuable time for evacuation and fire suppression. The NEC is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment. It is developed and updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is widely adopted by states and municipalities throughout the United States and serves as the basis for electrical codes in many other countries. The purpose of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC is not a design manual, but it provides the minimum requirements for safe electrical installations. It is the responsibility of qualified electrical professionals to design and install electrical systems that meet the requirements of the NEC. The NEC is constantly evolving to keep pace with new technologies and changing safety concerns. The NFPA develops and updates the NEC through a consensus-based process that involves input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, and inspectors. The NEC is an essential resource for anyone involved in the design, installation, or inspection of electrical systems. It provides the knowledge and guidance necessary to ensure safe and code-compliant electrical installations. The National Electrical Code Article 100 defines readily accessible as capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. The inspector is looking for accessibility.